All right, section 10.6, samples and populations. You've heard me use these words before. A population is an entire group of people or objects. A sample is part of the population. It's part of the population. It comes from the population, but not as large as the population. You can use a sample to make an inference, which is a fancy way of saying a conclusion or a prediction about a population. So you guys are doing your survey projects. On day one of our survey project, I identified our population for you. It was 7th grade Liberty students. Also on day one, you guys came up with a survey question and your answer choices that you were going to ask those people. On days 2, 3, 4, 5, 6, and 7, sounds like a lot of it's happening on day 7, you're going out and sampling that population. Remember, you have to get 25 names by, for you guys, it's tomorrow. When we meet during success time tomorrow, we're going to be right here on this step. We're going to be interpreting that data. We're going to be calculating the percent of students that you surveyed that said each of the answer choices. We'll be calculating a prediction of how many students in our hallway would say each of those answer choices. And then when we meet our final time during success, we'll be on this step here, make an inference or a conclusion. This is going to be that survey, the essay that you guys are writing for the survey project, which concludes your data. What did you learn? What was difficult? What was enjoyable? Those are all things that you can include in that essay. So we are probably right in this area currently, which is getting ready to interpret our data if you haven't already done so. I've got one student in first period who's already done with everything. It really doesn't take that much time. I'm not surprised. I'm surprised that he wanted to work ahead that well, but I mean, I'm not surprised because it really doesn't take you that long to do, especially once you know how to put your slides together. And that's what we're going to talk about tomorrow, is how we calculate the data on our slides, how we can do Google Slides, share our Google Slides with our partner. That's a big one. Make sure you're sharing everything. Make sure when you're writing your essay, it's on Google Docs and you're sharing it with your partner, because if they're not here, it's difficult to get stuff done when it's on their iPad. But if it's on both of your iPads, you can work independently. Okay, so let's talk about populations and samples. I'm going to give you two options up here, and I want you to tell me which one's the population and which one is the sample. First off, we have the students in a school and the students in a math class. Branson, which of those is the population? That's right. The population is all the students in that school, and that makes the sample the students in one of the math classes. It comes from the population, but not as large as the population. The next one, the grizzly bears in a park, with GPS collars in a park, or all grizzly bears in the park. Maddie Cheeseman, which of those is the population? That's right, grizzly bears in the park. That makes the sample the ones that have the GPS collars. Yeah, that bear is not dead. I'm sure it's been tranquilized, although, or just in a deep sleep, right? But those GPS collars will track where the bear moves, and so they can see what kind of habits and where it's been staying and stuff like that, so they can track where the bears are going. Part C, we have 150 quarters or all quarters in circulation. Maddox, which of those is the population? That's right, making the sample the 150 that we've selected. And then finally, all books in a library or 10 fiction books in a library. Jude, which of those is the population? Awesome, which makes the sample the 10 fiction books. Again, the 10 fiction books are coming from the library, just a sample of those all books in the library. So just it's part of the population, comes from the population. Okay. When a sample is selected at random, each member of the population is equally likely to be selected. That's why I've been making sure you guys are writing down the names of the people we've been surveying, because I want to make sure it's done randomly. If you don't do it randomly, then the results you're going to get will be biased. You've heard me say that word quite a bit. Okay, so I'm not saying you have to ask every member of the population. You're not going to be able to. But everybody had to have had a chance to be asked. If you just went to one room and surveyed students from one room, or for example, when we came up with our survey ideas, some of you guys were asking me, can I ask people in this room? Yeah, you just can't ask everybody in this room because that would give your entire population or sample from a chunk, just a chunk of the population that's biased, that's been favored over another chunk. All right, so I want you to tell me if these are random samples. You want to know that your the favorite extracurricular activity, that would be like a sport or a club that you would do after school, of students at Western Middle School. Determine whether each method would result in a random sample. You ask band members. Okay, I was going to put not random, but you guys already know that word biased, so we'll just put biased. Why do you think it's biased, Lucas? It's what? Say it again. It's just what? That's right. One group of the population, or one part of the population. Yeah, it's just the band members. I'm guessing a lot of them would say something band related, like marching band or something like that, right? Now, I'm not saying that band members can't be asked. I'm not saying that. I'm just saying that can't be your entire sample. You ask one person from each table in the cafeteria during the lunch periods. Is that random? Yeah, that would be random. Even if you're sitting with your friends, if you just ask one person from that table, you can't be biased with that, especially since there's a lot of tables and there's 3 lunch periods. You're going to include an equal number of 7th, 6th, and 8th grade responses to represent Western Middle School. So that would be a pretty good survey. You ask every 8th student who enters the school. Is that random? Yeah, you have no control over who's going to be the 8th person to walk in, or the 16th, or the 24th person, and so on and so forth. So that would be random. Even if you walk in with all the band members, because they always hang out together and they're always biased, right? It's always the band members that are biased. Just kidding. But yeah, if you just ask 1 out of every 8, you're only going to get 1 of those band members. You're only going to get 1 of the football players, or whatever it is. So you get a nice chunk of a random chunk of people. You ask students in your SLT. Biased. Why is that biased? Yeah, just 1 SLT. Every student has SLT now, but you can't just go to one room. That means you're favoring one SLT over the others, and that's what it means to be biased. All right, to make valid inferences about a population, you must choose a random sample so that it accurately represents the population. So what we're going to do now, I'm going to read off the results of a random, well, not a random, I'll read off the results of a survey. All of the data from the results is accurate. I'm not asking you if it's not accurate. It is. What I'm asking you, is it valid? Is it good data? Is it usable? Or did the way they conduct this survey give them accurate, but bad results? I'm not asking you if they did the math right. I'm asking you, did they do the survey right? A new power plant is being built outside of town. In each situation below, residents of the town are asked how they feel about the new power plant, determine whether each conclusion is valid. A local radio show takes calls from 500 residents. The table shows the results. The radio station concludes that most people in the town oppose the new power plant. According to their survey, they'd be right. But I'm not looking at the numbers right now. I'm asking you, is the way they conducted the survey right? Would you say this is a good survey or a bad survey? And if it's bad, I want to know why. And if you think it's good, I want to know why too. They took calls from 500 residents. Jude?
It's good.
Why is it good?
Because they did a large amount of people, and they didn't just do the 4, they did both sides of the whatever.
Okay, so they asked if they were for, against, or don't know. Okay, so those are 3 good options. I do agree with you when you say that the sample's large enough. 500 is a very good chunk. It's a very big chunk of that town. Okay. I don't think it's a good survey though. There's something about this that's just going to skew those results one way over the other. Frank, what do you think? No, it had all three of the options, for, against, or no, sorry, the circles for part B. Yeah, we're just looking at this chart right here. Actually, we're not even looking at the chart right there. We're just looking at these words. What about this makes it a bad survey? Jude, you want to change your mind on it?
Yeah, there's not very many.
Doesn't matter to me. I'm not looking at the results of the survey. I'm looking how they conducted it. Alexis? Yeah. Not everybody's gonna call in, or really not everybody's gonna listen to that one radio station, right? So first of all, you're only getting answers from the listeners of one radio station. Second of all, they're calling in. Why do you think they're calling in? Because they're upset. Do you call in when you're for something? You could. I feel like you'd be more emotional if you were upset about something, right? More likely to call in. I mean, and that's exactly what I'm seeing. 425 out of the 500 people that called in said that they were against the power plant. They were motivated. Yeah. So even if that's not true, it's still one radio station. So you're only getting listeners of that one radio station. So this would be invalid results. Lainey, could you shut the door for me? Thank you. Let's look at part B. A news reporter randomly surveys 2 residents outside of a supermarket. The graph shows the results. The reporter concludes that the residents of the town are evenly divided on this new power plant. Maddie, you're shaking your head. What's wrong with the way they conducted the survey? Yeah, they only surveyed 2 people. So from the results, I'm looking at the pie chart, which I don't have to peek the pie chart, but if I do, I can see that one person said they were for it. One person said they were against it. So therefore, the town has been evenly divided over this issue. You just asked 2 people. Now, you randomly asked 2 people. That's fine. I like random. I don't like it only being 2 people. That sample is not large enough. So this is, again, going to be invalid. Meaning their results aren't worth anything. I'm not saying they didn't calculate it correctly, but I'm saying the way they gathered their data, not good. You randomly survey 250 residents at a shopping mall. The table shows the results. Again, not really interested in what the table says. I'm more interested in how they conducted the survey. So you conclude that there are twice as many people that are against the power plant than that are for the power plant. What do you think about this survey? Is 250 people large enough? Okay. Was it done randomly? Yeah. Did it include all parts of the population? This could get fuzzy because this could get fuzzy because I don't know how big this town is. I don't know how many shopping malls they have. How many shopping malls does Kokomo have? Just one, really, right? So I mean, the size of Kokomo. Now, if you're thinking not every part of this population was surveyed, you're right. But also, can you be at everywhere at once? Is there one place you can go that everyone's going to go? Where? Home. So you're going to go to everyone's, you can be in everyone's home. Yeah, that's creepy. Is that you?
Yeah.
I would say the 250 is large enough. It's done randomly. You did it at a shopping mall, which means you're going to get all parts of the I won't say everybody's coming into the mall. We can agree that not everybody's going to come into the mall, but people from all over town are going to come to that mall. This is about as good as you can get here. So we'll say that this is valid. These results are about as valid as you can make this particular survey. Really? Thank you. Let's do another one. You want to know the residents of Kokomo, how the residents of Kokomo feel about the ban on texting while driving. Determine whether each conclusion is valid. What's our population? What's our population? Who does it consist of? Who does it consist of? Kokomo residents. Okay, the 200 is our sample. Okay, so we have to make sure that number one, the sample includes all aspects of that population. Number two, the sample is large enough. Number three, the sample is done randomly. You survey 200 students at random, residents, not students, 200 residents at random. 164 residents support the ban and 36 don't. You conclude that 82% of the results of the residents of Kokomo support the ban. Now, the 82% is accurate, so don't get caught up on that. 164 out of 200 is 82%. I'm asking, is this a good survey? Is it large enough? Is it random? It says random right there, right? Large enough. Did it include Kokomo residents? Then this looks like this is valid. Part B, you survey the first 15 residents who drive into your neighborhood. 5 support the ban, 10 do not. You conclude that 33% or 5/15 or 1/3, that's correct, of the residents in Kokomo support the ban. Valid or invalid? Invalid. Give me a reason why it's invalid. Shout it out.
They drive into your neighborhood, they live with you,
Your neighborhood.
and they also, there's not very many.
Too low. You're asking more people in your survey project out of 88 people. This is supposed to be the entire residence town of Kokomo, right? Also, your neighborhood. If you just ask people from your neighborhood, you are favoring one part of the population over the other. That's because you're being lazy, right? So it's too small. You're asking people just in your neighborhood. You have to make sure, I'm not saying you can get out to every neighborhood, but maybe go to a supermarket where, you know, lots of people are going to come in and you can get a feel for the entire town that way. Okay, an unbiased sample represents the entire population. It is selected at random and is large enough to provide accurate data. We want to be unbiased. Remember what that word biased means. You're favoring one part of the population over the other. Okay, a biased sample does not represent the entire population for that reason. When I think of bias, my ultimate example when I think of bias is imagine that you and your mortal enemy are competing against each other in a talent show. And their mom's the judge. Right? You don't stand a very good chance. Should that be the case? Shouldn't be if the judge that was impartial was up there, right? So that's what I think of when I think of biased. Now, that doesn't mean you can't survey your mortal enemy when you're doing your survey projects. What I'm saying is you can't favor one part of the population. You can't just go to your friends. You can't just go to all girls. You can't just go to the band members because it's always them. You have to make sure that you're randomly surveying all people or all different parts of the population. Okay. Now, if your population is small, like it's Liberty students, you might say, well, I'm not asking any Freedom students. Well, they're not part of our population for a survey project, so I don't have to go outside of the population, but I do have to randomly ask students that are within our population. Okay, so now we're going to determine whether the sample is biased or unbiased. Now, remember, unbiased means random and large enough, not 2 people. Okay, we want unbiased surveys. You want to estimate the number of students at Western High School who ride the bus, high school students. Determine whether each sample is biased or unbiased. You ask 4 students in the hallway. Why is it biased? Too small.
And it's in your hallway.
Yeah, I mean, well, I didn't say your hallway, but still, there are junior hallways, senior hallways, freshman hallways, sophomore hallways. There is the math, all the math rooms are in the same area, all the foreign language rooms are in the same area, all the science rooms. So you're going to get biased if you're just asking 4 students from a particular hallway. And number one, yes, it is way too small. We're thinking probably 900 to 1,000 students in the high school. 4 students. How about all the students in the marching band? It's always the band members. Yeah. Yeah, I'm not saying you can't ask band members, you just can't only ask band members. Well, here's why I have put marching band in here. It seems like, especially during the fall, every morning when I drive into school, they're all out practicing. So if you asked a marching band member, how many do you think ride the bus? None of them. Because they're out there practicing at 6:30 in the morning. Buses don't arrive till 7:20, so they wouldn't be able to. So again, you can't, they're all going to say no. So the results I get back from that survey would be entirely wrong. Even if I calculated all my percentages correctly, 1% of students ride the school bus. That's not right. It's not a good, valid data. 50 seniors at random. It's done randomly. Why is it not valid? Just seniors. You're right. It's biased. There are freshmen, sophomores, and juniors that are a part of the high school. Now, if your sample was only the seniors, then of course you're only going to ask seniors, but it was students at Western High School. So that's only one part of our population. What about 100 students at random during lunch? This would be unbiased. Yeah, now there are, I believe, 3 lunch periods in the high school like there are in the middle school. So you'd want to make sure you are asking people from every one of the lunch periods. But yeah, as long as you're doing that to get your 100 people, you'd be fine. Yes, Lucas. For for food. Yeah. Yeah, it's nice to be a high school student. Yes, Jude.
Did you go to school here? No.
Hunter? Yes. All right, now we're looking at 7th grade students at Western Middle School. You want to estimate the number of 7th grade students at WMS who consider it relaxing to listen to music. Determine whether each sample is biased or unbiased. You randomly survey 15 members of the band.
What's wrong with you?
Of course it's biased. They're band members.
Oh my God. That doesn't make music relaxing.
Yeah. Wouldn't they like music? I mean, they make it every day, right?
And they're 7th grade, they're only 7th grade.
Well, true. But you're only asking 7th grade people. That's our population, right? So it's good to know what your population is. Make sure your sample includes all parts of that population, not just the 7th grade band members. Also, another thing you could have gone with here. You're only asking 15. Not big enough, too small. Your friend surveys every 5th student whose name appears on an alphabetical list of 7th graders. Unbiased. Again, this is why I remind you to know your population, because I had someone from last period say, well, they're only asking 7th graders. Well, yeah, that's our population. Yes, we weren't doing all students at Western Middle School. We were just doing the 7th grade. So of course, you're only going to ask 7th grade students. Though. Okay. All right. The results of an unbiased sample are proportional. If it's unbiased, remember that's good. Unbiased means random, large enough. The results of an unbiased sample are proportional to the results of the entire population. You can use unbiased samples to make predictions about the population. Have we been using proportions to make predictions at all this chapter? Absolutely, we have been. We can do that again right now. In fact, that's what we're going to do when you guys come in during success time with your data. We can start making predictions. This particular student asked 75. We only asked 25. So, but the way we're going to do it is going to be very similar. You asked 75 students, randomly chosen students. So this is a good survey then. How many movies they watched each week? There are 1,200 students in this school. Of the 75 that they asked, 21 said they watch 1 movie a week, 24 said 2 or more, and 30 said they don't watch any movies during the week. Predict the number of students in the school who watch 1 movie each week. So when we set up our proportion, we're going to have our sample ratio and then our population ratio. How many students that were sampled said that they watch 1 movie a week? 21 out of not 1,200. You asked 75. So if 21 out of 75 say that they watch one movie a week, then how many out of, how many is in our population? 1,200 or 1,200 would say that they watch one movie per week. See how that's set up? Just like we were doing it last week. 21 out of 75 students would equate to how many out of 1,200? And so we cross multiply, have your calculators ready. I'll do 75 times X. About all my brain can handle. Caden, I want you to do 21 times 1,200. $35,200, is that what you said? 25,200. Thumbs up or thumbs down? Do we agree? Aiden, I'm getting a lot of thumbs up. All right. Now, Addison, would you divide that by 75 and tell me what our prediction is then? Addison Klein, sorry. 336, and it's a story problem. We'll label that students. And that's exactly how we're going to make our predictions on our survey project, except you're only doing out of 25 and your population's out of 88. Part B, predict the number of students who watch 2 or more movies in a week. 2 or more. Rayleigh, how many students that we surveyed watch 2 or more movies in a week? $24. And how many did we survey? It's in your notes.
Oh,
How many did we survey?
I didn't write them down.
It's in the, I need you to be paying attention.
Okay.
How many students did we survey? 24 out of. Look in the example problem.
I don't know what I'm doing right now, Parker.
Frank, how many students did we survey? 75. Rayleigh, you pay attention. You're going to go to the office.
Okay.
24 out of 75 students said they watched 2 or more movies in a week. Could be 2, could be 3, could be 15, because that's all they do. So again, just like last time, we're going to make that prediction for our population. So if 24 out of 75 watch 2 or more movies, then how many out of 1,200 in our population? So again, there are 1,200 in our population, 75 people that we asked. And so we can cross multiply this to set up a proportion. I'll do the 75 times X. Maddox, can you do 24 times 1,200, please? $28,800. Okay. And Alexis, will you go ahead and divide that and tell us what our prediction is? It would probably be easier if we had our calculators next time.
I know it. I have the answer.
I'm not asking you though.
Hope you do.
What'd you get, Alexis? 384.
That's my gut too.
Okay, yes. This is B. I was thinking we were on C, or not C, but the next problem. Yeah, 384, and then we'll say students. Now, if you wanted to know how many students you would predict that watch 0 movies, you could do 30 out of 75 instead of your proportion again. Or there's actually another way, since you know how many predicted students watch 1 movie and 2 or more movies, you could just subtract those from 1,200 and get whatever's remaining. So you have a couple different ways. Yeah, but we're not asked to do that here. So we're going to jump to our last example, which is another survey. You ask 50 randomly chosen students at Western to name their favorite sport. There are 680 students in the middle school. So I guess this should say Western Middle School then, because Western would be like every student. There's a lot of students at Western. So predict the number of students in a school who would name soccer as their favorite sport. Oops, that just changed my, I got to bump these over now. Hello. There you go. Bum, 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 bum.
How long does it take you to make the notes?
A little bit, but I reuse them over and over. So, oh, come on. What's going on? Nope, can't do that. All right, I guess that's as good as it's going to get. So we asked 50 people. Thomas, how many of those 50 people said they like soccer as their favorite sport? 12 out of 50. Okay, so there's our sample ratio. Ella, what's our population ratio going to say? If 12 out of 50 people that we sampled like soccer, then that's right. How many out of 680? That's the question, and we're going to cross multiply to figure that out. I'll do 50 times X. Laney, can you do 12 times 680 for me, please?
Oh.
Okay, so 8,160. All right. And then Natalie, would you divide that by 50 and tell us what our prediction is going to be? 163.2. Now, this is likely going to happen when you guys are doing your predictions on your survey project, which is getting a decimal answer. When you get a decimal answer, obviously we can't say 0.2 of a person. So we're going to round to the nearest whole number. Is that closer to 163 or 164? 163. So we'll say about 163 students. Yeah. So again, when you're doing your survey projects, do the same thing. If you get 0.2, if you get 0.8, round it up. Count 0.3, round it down. 0.4, round it down. 0.5, round it up. Okay. All right. That's our notes.